Unit Operation Classroom. Today we are discussing area enclosed by a polar curve. We look into what is the polar curve and how to find out area. My name is Shekhar Bhattacharjee. According to this problem, the polar curve is, the curve in the polar coordinate system is expressed by, given by this particular expression here. And we have to find out the area enclosed 0 to 2 pi. 0 to 2 pi. And we'll see what is the envelope or profile of this particular polar coordinate curve, and then we'll find out the area. So we'll first discuss some basics of the polar coordinate system. By the way, this is the equation of a cardioid, and the typical general equation for the coordinate system is given by this equation here, where a is greater than 0. For us, this is 2 times 1 minus sine theta. So here, of course, r is equal to 2. So we're going to see how this envelope looks in the Cartesian coordinate system, and then, of course, in the polar coordinate system. This is the expression we are going to use. In the polar coordinate system, any particular point, say p r theta, is given by r is r theta, where r is the distance from the pole origin O to P. So this is the distance. Remember, this is the distance r. Okay, so that's the value of r, and theta is the angle measured counterclockwise from positive x-axis to ray OP. So this is my positive x-axis. Of course, this way is negative axis. So we'll measure from the positive x-axis up to this particular ray here, OP, what this angle is given as theta. So that's the way we discuss or describe a polar point. So let us look into this particular graph here. Here, first we'll see in this circle how we describe this point P or theta in Cartesian coordinate system, and then we'll see what is the equivalent polar coordinate system. In the Cartesian coordinate system, as you can see, this distance, if this P is r theta, point P is r theta, so r is the distance here. So this is the value of x is equal to r. So this is r, and y, of course, is 0. So this is the point r0. If we move 90 degrees, then of course we can see the value of x is equal to 0 here at this point here, x is equal to 0. But the value of y is equal to r, right? Y is equal to r. So this point is given as 0 r. In this direction, as you can see, this value is negative r, and of course value of y is 0. So this is negative r0. And in this point, of course, x is equal to 0, and this the y value y is equal to negative r. So these are the points described as it travels the 0 to 2 pi in the Cartesian coordinate system. In the polar coordinate system, we know it is expressed as r theta, where r is a distance. So here, at this particular point, the distance, of course, is r here, and the angle is 0 because it starts counterclockwise from the positive axis. So here, the point is 0, so this is r0. So as we move 90 degrees, of course, this remains, r remains same as r, but we have traveled 90 degrees. So this is r pi by 2. So this point is r pi over 2. And here at this particular point here, of course, the distance remains same as r, but the angle is now pi. So r pi. And at this point, of course, of so this distance remains r, but the angle, of course, is 3 pi over 2. And as it moves again, this point becomes again r 2 pi. So r0 and r2 pi are the same, and it keeps on rotating and repeating. So this one is a Cartesian coordinate system, and this one, of course, is the polar coordinate system. Same points. Now let's see in the polar coordinate system and the Cartesian coordinate system how the equation which is given to us, how that looks like. This is r is 2 minus 2 sine theta. So here let's say theta is equal to 0. So theta is equal to 0 means on this axis here, r is equal to 2 times 1 minus sine theta. This is given to us. And sine theta, of course, is equal to 0. So this is going to be equal to 2. X is equal to r cosine theta and y is equal to r sine theta. This is equal to 1. So this is equal to 2. And r value is 2 is 0. So this is 2 0. So this point is 2 0. And in the polar coordinate system, r is equal to 2 and theta is equal to 0. So as you can see, this is according to the Cartesian coordinate system. So this is 2 0, y is equal to 0, this is 2 is 0. And in the polar coordinate system, this is distance is r2 and the angle is 0. So this is right here. So let's look at the next point. For theta is equal to pi over 2, when we travel at an angle of pi over to 90 degrees, then as you can see r changes. This is equal to 1, we know. So this r becomes equal to 0. So x is equal to 0, y is equal to 0. And polar coordinate system r is 0, and this is pi over 2. So this is 0, 0 in the Cartesian coordinate system. And in the polar coordinate system, this is 0 pi over 2. So as you can see in the Cartesian coordinate system, this comes at 0, 0. And in the polar coordinate system, this becomes 0, r is equal to 0. That is distance from the origin. And the angle is, of course, pi over 2. So right here. So this is traveled like this. This is the cusp here. Okay. Uh, Next, of course, we'll see one more. Theta is equal to pi. So sine pi, of course, is equal to, we know, is equal to 0. So this is going to be 2. So if we do this one here, so this is cosine pi is, of course, negative 1. So this is negative 2, 0 and 2 pi. So here, as we can go here, this is x is equal to negative 2 and y is equal to 0. So this travels here. So it travels from here and then here. And here, as you can see, r is equal to 2. And this is equal to 5 from here. So it has traveled like here, exactly the same one. So these are, of course, shown here in our website, all the details, and you can see the details. So this is how basically this cardioid looks like. Okay, so this is a downward facing cardioid. Now we have to find out the area of this cardioid here. Okay. So how do you find out the area? Area enclosed by a polar curve is given by, let's say here. So we a small circle here, and this is circular segment, and the area of this one is dA is given as half r squared d theta. And for us, r is 2 into 1 minus sine theta. So once you put this one right here, so that's what it comes to be. So this is 2 squared comes as 4 here, 4 over 2. And this is 1 minus 2 sine theta plus sine squared theta d. So this is now easy. This is 1 d theta, 0 to 2 pi integral with 0 to 2 pi. And this is the sine theta d theta, 0 to pi, and this sine squared theta. Now, this is the sine theta integral of 0 to 2 pi sine theta d theta is equal to 0. And integral of 0 to 2 pi sine squared theta d theta is equal to pi. How? We'll look into it very soon. So this is 2 times 2 pi, which is 4 pi. This is 0, and this is 2 pi. So the answer is 6 pi. So 6 pi, option D is the correct option here. So this is the correct option. Okay. Um, by the way, for a deeper understanding, always refer to standard textbooks and your, of course, class selection books. Why integral 0 to 2 pi sine theta d theta is equal to 0? Very easy. This is shown here to 0. And similarly, y 0 to 2 pi sine square d theta is equal to pi. I have shown this is cosine of 2 theta is equal to 1 minus 2 sine square theta, and sine square theta is this one. So we substitute here, and this becomes equal to pi. That is also shown. And I'm just for curiosity's sake showing how the sine theta curve, of course, this is the typical sinusoidal curve. And of course, this cancels this one. So this is the area 0 to 2 pi is equal to 0, whereas sine squared theta, of course, is this particular curve right here. And this area under this one is equal to pi, which we have seen. What is the practical application of this problem? Well, let's see. Suppose there is a spray here. Could be something like spraying metal parts or spray dryer, whatever. Suppose the spray contour of the spray nozzle is given by R2 minus 2 sine theta, and the liquid fluid required is this 0.5 liter per meter square per minute. So you can find that out. So let's the volumetric flow rate, and this is fixed bar. So if we so the steep part, so that 9.4 liter per minute. This is just an example how this could be useful. This particular problem could be useful in solving an industrial problem. So finally, the correct option is, of course, D is the correct option.